the world is changed. And some things that should not have been forgotten were lost.
But the observing proposal has been approved.
What must I do?
The sky must be observed.
At the telescope on Mount Doom.
You have my targets.
My coordinates.
And my
mortal.
You carry the fate of us all, little one.
This task was appointed to you, and if you do not find a way, no one will.
You will face evil, and you will defeat it.
Even the smallest
student
can change the course of the future.
If the mountain defeats you, will you risk more dangerous road to the observatory?
Stand up! We must turn back! No! We must get up the mountain! Make for the Gap of Rohan! I take the west road to my city! The Gap of Rohan takes us too close to...
Light pollution.
We're gonna pass over the mountain! Let us go
to Guildford Hall Brewery.
Let the grad student
decide.
We cannot stay here! This will be the death of the...
students.
Frodo?
We will go to the bar.
So be it.
2 hours later.
What's that?
This, my friend, is a pint.
It comes in pints?
Oh.
I'm getting one.
You've had a whole half already!
Sweet is the sound of the pouring rain, and the stream that flows from hill to plain, better than rain or rippling brook. As someone go beer and
science.
Later that same evening.
Well, if you saw our event posted to Reddit or social media or whatever, you might have seen that the third talk of our evening was supposed to be Dr. Amanda Dodson talking about sci-fi and astronomy. She unfortunately became ill as of like yesterday afternoon and had to drop out at the last possible second. But we were super fortunate because one of our organizers and just all-around awesome badasses who made the intro video and is an amazing person, Dr. Lepo, is here. She is going to be giving a talk that's probably going to be just as cool called That's Not Tattling. So take it away.
All right.
So yes, my name is Dr. Kelly Lepo. I work at the Space Telescope Science Institute. And you know, there's certain emergencies that everyone is prepared for. And the emergency that I am prepared for is help. Someone needs to give an astronomy on Top Tap tomorrow. So, is a Star Wars rant. I have opinions about the planet Tatooine. So this is Tatooine. Maybe you've heard of it. It was featured in the 1977 film Star Wars. Let's see if I can. I'm gonna juggle. Okay. It is home to Luke Skywalker and also Anakin Skywalker, I guess, if you're a prequel fan.
Who is it?
We can go to everyone's favorite source, Wikipedia, and we can look up what they have to say about the planet Tatooine. So there's a lot of lore in there, but we're interested in the science. We're going to do the science of Tatooine. And here's the science. It's part of a binary star system. It's orbited, the planet orbits 2 scorching suns, resulting in the world lacking the resources necessary to have enough surface water to sustain a large population. Okay, I mean, that's something. We can go to our primary source. This is a very famous scene. Here we have our hero, Luke Skywalker, and he is watching the suns set.
Yeah.
So this effect was done by just overdubbing the real sunset twice. So we can assume, perhaps, that Tatooine orbits 2 sun-like stars. Okay, sure, why not? So let's introduce some more science. Let's talk about this concept that astronomers had called the habitable zone. As I like to say, this is a planet in the habitable zone is somewhere where you can brew beer. It has to be not so hot that the water immediately evaporates. It has to be not so cold that your water immediately freezes. And you have to have enough microbes, little yeast, that can eat the sugar in your grains and turn it into beer.
Tasty.
Yeah, exactly. That is my definition of habitability. And so the distance from your star, there's different types of stars. Very hot stars will have a habitable zone that's further out. Very cool stars will have a habitable zone that is further in. So we can look at different types of stars and do a little bit of math, and we can figure out where their habitable zone is. So there's another idea, and we'll draw on our example of Luke Skywalker. So Luke Skywalker walked out of his home to go watch his lovely suns set, and he didn't immediately die. And that is because his planet has an atmosphere, right? So he's on a rocky planet, and this rocky planet has an atmosphere. So how can you figure out if a rocky planet has an atmosphere? Well, this is a question that astronomers are currently struggling with. So they're going to make a graph. This is when astronomers have a problem, they make a graph. So we're going to make a graph. And we're going to plot here the cumulative amount of X-rays and extreme ultraviolet light that our planet has accumulated over the history of the planet, where 1 being the amount that Earth has, and you can have more or less. And then we'll plot that versus the escape velocity. So that's like how good your planet is at like having things escape. So the higher your escape velocity, the faster you have to be going to escape from the planet. And we can make an example of our own solar system. So we know that some planets in our solar system have atmospheres, most of them. Some planets don't. Mercury doesn't. It's a bare rock full of craters. And Mars is kind of the marginal case. It has an atmosphere, but just barely. So let's draw a line, just by hand, on our plot. And we'll say that everything above the line probably doesn't have an atmosphere, and everything below the line probably doesn't have an atmosphere. So if you're Luke Skywalker, you don't want to be above this line because you don't want to die. Okay, so now we can do the same thing, but with all of the exoplanets we have discovered. So exoplanets, much like the fictional planet Tatooine, are planets that orbit stars other than the sun. So we can plot all of the planets that we know. We can guess at these two parameters, the escape velocity and the total amount of X-rays and ultraviolet light they've accumulated over the lifetime of the planet. And we can make a plot like this, and we can draw a line based on our solar system, and we will call this line the cosmic shoreline. Ooh, right? That sounds cool. And we'll say everything above this line probably doesn't have an atmosphere, and everything below the line maybe does. So if you're Luke Skywalker, you want to be below the cosmic shoreline. So this is a hypothesis. We don't know. You can notice that most of the planets we've discovered are above this line, probably don't have atmospheres. So right now, like as we speak, there's a group of scientists who are going to try to test this hypothesis of the cosmic shoreline. They have 500 hours of time on the James Webb Space Telescope and 250 hours, 250 orbits on the Hubble Space Telescope to try to figure out whether these planets have atmospheres or not. So this is to be determined, so we can't use this for our Luke Skywalker case, but just keep this in mind. We don't know if any of these planets around other stars we have discovered have atmospheres or not. So we're going to go back to this idea of the habitable zone, the zone in which one can brew beer. And if we were going to make a graph for Tatooine, it would look something like this. So Tatooine orbits two stars. According to Wikipedia, these are Tattoo 1 and Tattoo 2. This is not how astronomers name stars. This annoys me. It's okay. Tatooine orbits, but it orbits, but it's probably like inside of the habitable zone, sort of very on the edge. It's an edge case. There's not a lot of water in its atmosphere. That's why Luke Skywalker has to live on a moisture farm. Sure, why not? Okay. So this green area we'll call the habitable zone. So Tatooine, habitable, yes. Luke Skywalker doesn't immediately die. Rocky, yes. Sun-like stars, sure. And it includes Luke Skywalker. So this will be our criteria for if a planet is in fact just like Tatooine. Okay. So one might ask, pull up my notes here because I do not have this all memorized because again, it asked me yesterday.
Thank you.
Yay. Okay, here we go. Okay, so there are in fact 14 known planets around 12 known stars, or 12 known star systems, that are in fact orbiting two stars. So this idea of a planet orbiting two stars is in fact not that far-fetched. This is science fact, not science fiction. Most of these planets, all of these planets in fact, have been discovered by one of two telescopes. So on the left here we have the Kepler Space Telescope. This was launched in 2008 and went until 2018, and the successor to Kepler is TESS, and that was launched in 2018. So these telescopes do this, they use the transit method to observe planets. They're watching planets go in front of their stars, or monitoring the brightness of these stars, and when a planet passes in front of their star, there's a little dip in brightness. So what you should be thinking in your head is up top. You have a planet going in front of the star. What we actually observe is this bit down here. So we're not observing this, we're not resolving the star, we're not resolving the planet. All we are watching is the point of the star get slightly dimmer periodically. If you get a steady brightness and then a dip, steady brightness, dip, steady brightness, dip, that's the sign that there's a planet there. There's another method actually for discovering planets. This one used to be the method everyone used, but then Kepler just blew everything else out of the water. But you can actually look for the teeny tiny motions of a star using this this radial velocity, that like ambulance, pitch gets higher, pitch gets lower method. So you're not resolving the star again, but if you look at the spectrum of the star, you can see it shift a little bit red, a little bit blue, a little bit red, a little bit blue, and that tells you that there's in fact an exoplanet tugging on your star. So those are like the two main exoplanet hunting methods. There are others, but that's okay. So, images of planets. Every image I'm going to show you from here on out is an artist's illustration. But if you want to see what a planet actually looks like orbiting around another star, here we go. So the star is in the middle here. It is helpfully marked by a star. We have put a disk in front of the star because the star is super duper bright, and when doing that, we can reveal the faint planets orbiting around it. So all of these little points of light that we see moving in this image are in fact planets. Not like the junk near the star, that's noise, but like the 4 little dots here, those are planets orbiting around the star. This is the best image of a planet you're gonna get. And even then, we're not resolving the disk of the planet. They look a little bit bigger, but that's just because it's blurry. So really, these are just points of light. Okay, so now we get into my beef. Okay, we're gonna pull my nose back up because again, yesterday. Okay. So this is Kepler 16b. This is an artist's illustration of Kepler 16b. So we have a planet and it is orbiting around 2 stars. One is sort of a sun-like star and one of them looks kind of little and red. Okay, let's see what the press says about this planet. From Star Wars to science fact, Tatooine-like planet discovered. Okay. Tatooine planet, Kepler 16b, orbits 2 suns. Planet like Star Wars, Tatooine discovered. Exciting. So this is from 2011. This was the first planet that we found orbiting 2 stars. So here is a screenshot from NASA Eyes on Exoplanets. It's a cool app. You can go explore any exoplanet system you want. Here's Kepler 16b. The green is the habitable zone, that zone in which you can brew beer. And hey, we're looking pretty good if we are Luke Skywalker on this planet so far, okay? We have the 2 stars in the middle, Kepler 16a and Kepler 16b, capital letters. That means the star. And then we have Kepler 16b, lowercase, that means the planet. Yes, this is a bad naming system. Anyways, going on. Oh, here's a problem. Okay, so here is our solar system, and here is Kepler 16b to scale. You might notice something. This planet is enormous. It's kind of, Saturn-sized. Okay, so let's review our criteria. Is this planet just like Tatooine? Habitable, sure. Rocky, no. This is a gas giant planet. Sun-like stars, only one of them is sun-like. Luke Skywalker, no. So, verdict. Not just like Tatooine. Moving on. Kepler 35b. This was the second planet orbiting 2 stars that we discovered. What does the press say? Oh, we're like Tatooine. Okay. Let's look at this. Oh, here's our chart again. Well, look at that. It is inside the habitable zone. Oh no, Luke Skywalker. All of the water on your planet has evaporated into space. Also, your planet is enormous. That's bad news. There's no surface. Okay, Kepler 35b, not habitable, not rocky. The stars are in fact sun-like, or one of them is sun-like and one of them is close enough. And no Luke Skywalker, verdict, not just like Tatooine. Continuing on, boo, I know, right? Okay. Kepler 453b, I think this was the 10th planet planet that we saw orbiting 2 stars. What does the press say about it? Similar to planet Tatooine from Star Wars. Okay. Let's see. Is it in the habitable zone? Well, look, it's right on the inner edge, just where we want it to be. Maybe this one is just like Tatooine. Oh no, it's too big again. Oh, there's no surface. So it's habitable, but it's not rocky. And only one of the stars is sun-like. And there's no Luke Skywalker. So not just like Tatooine. Okay. Kepler 1647b. Well, this is looking promising. These stars are both kind of yellowish. Although we will never watch 2 suns rise and fall from the perspective of our own planet like Luke Skywalker on Tatooine. The iconic scene from Star Wars A New Hope, there is a newly discovered planet where aliens might do so. Oh, is this true? Have we found Tatooine? Oh no, move over Tatooine. Kepler discovers the largest ever Star Wars style planet orbiting 2 stars. Okay, it's in the middle of the habitable zone. This is looking promising. Oh no, it's too big again! There's another gas giant! Oh no! Okay, so it's habitable, it's rocky, it has sun-like stars, so it's habitable, it's not rocky, it's a gas giant, it has sun-like stars, and no Luke Skywalker. Disappointed yet again. Okay, so now we will go to the latest discovery on my list. This is, in fact, the first planet to be discovered not by Kepler, but by the TESS mission. So this is TOI, TESS Object of Interest 1338. We actually have 2 planets here, Planet B and Planet C. Planet B was discovered through the normal transit method, and Planet C was actually discovered by the radial velocity, that wall method, that like ambulance method. So this is Planet C was the first planet discovered around 2 stars by the radial velocity method. Okay, pretty cool. Are these Tatooine? Well, if you look at the press, yes, they are. How we found a Tatooine world with 2 suns. This is an interview with a scientist. New Tatooine-like exoplanet discovered orbiting twin suns. So Bebop is actually a name of the radial velocity survey they found it, so that's another name, an alternate name for the planet. Okay. Oh no. New Star Wars planet is nothing like Tatooine!
What? I want my money back.
It's unlikely to be able to host life forms, even Jedis. I like that there's an exception for Jedis. Like Jedis are some sort of like very weird life form that can live on very weird planets, but not this one. Oh no! Oh no, Luke Skywalker! Again, you're inside of the habitable zone. All of your beer has evaporated. You can't live there. Also, your planets are enormous. So one's like Saturn size, and the other one is a little uncertain, but probably Jupiter-sized dish. There's no surface to watch your sunsets from. Okay, so it's not habitable, it's not rocky. Only one of the stars is sun-like, the other one is a tiny little thing, and there's no Luke Skywalker. So, in conclusion, is that planet that you saw in the news just like Tatooine?
No.
No!
No.
It's not just like Tatooine, stop saying that! Oh my god! But, okay, that doesn't mean they're not cool, right? Like, this the thing about space and why I love it so much is it's so weird. Space is weird. And all of these planets are even weirder than what George Lucas could think up. So maybe the fact that they're not exactly like Tatooine is in their favor. And they're all really awesome. Thank you.